You can hear me?
Hi, yeah, I can hear you.
So what about the other problems in the horizontal launch you could do?
Yeah, I did the second one.
Okay. So you got the answer right?
Yes, I did.
Have they given the answer key?
Yeah.
Okay. So you can see the screen.
Mhm.
So you understood the steps, right?
Yeah.
Okay. See here, just a minute. You can see my pointer.
Yeah.
Okay. Here I'm analyzing the y motion, and I put v equal to a naught plus v naught. To make it clear, I put a suffix y.
Because it's your velocity for y, your
Yeah.
vertical velocity.
Yeah. Velocity will have two components, right?
Mm-hmm.
Vy and Vx. If you want to make it more clear, you can put this suffix because here I'm combining both.
Mm-hmm.
So I just wanted to make a difference. So I put suffix x here when I get from x
Mm-hmm.
motion, and from y motion I get Vy,
Mm-hmm.
right? Okay. And this equation y equal to minus gt square, half gt square. It's a parabola, and we inverted parabola, so it'll be like this.
Yeah, yeah, I drew the graphs and everything.
Okay. So what do you want to discuss now?
I sent you something called Worksheet 16. I don't know if you saw it. I think I sent it to
Uh,
you like this morning or afternoon.
okay.
Like
Okay. That
different.
okay. That I'll do it tomorrow. I'll send the this file for that. See, the only difference, see, horizontal launch means the initial velocity is
Mm-hmm.
horizontal.
Okay.
Okay, so there is no vertical component of the initial motion.
Mm-hmm.
Okay, but when it's symmetric launch,
Yeah, we talked about that. I think I sent you the doc.
just a minute. I'll give the general idea. So this is ground, okay, and you're projecting at an angle. Okay, so the thing will move like this, and it hit the ground here, right? Is it clear? See, the difference between the previous one and this one is here the initial velocity u.
I can't see you or anything. It's just a black screen. I can't hear anything.
Uh, Screen is shared or not? You can see the screen.
Um, okay, so my internet disconnected, so I'm gonna connect and see if I can. I don't know if you can hear me or anything.
Yeah, I can hear you. You can see me now.
Yeah, I'm back. Sorry, my screen froze. It was black. I couldn't see anything.
Is it working now?
Yeah, I can see it.
Okay, so uh, see this thing represents a rigid surface. When I draw a
Mhm.
line and put a short dash like this, a rigid surface. So the Earth surface, ground, I'm shooting a projectile or a body
Okay.
with the velocity v naught. Okay, so
Okay.
initially, uh, see here, this angle is some theta, right?
Yes.
So it will have two components.
X and Y, horizontal and vertical.
Yeah, I'll choose x-axis like this
Okay.
and y-axis like this.
Okay.
So the origin is here then. Okay, so it will have v naught cos theta, and this is v naught sin theta, and this v naught cos theta is v naught x component, and v naught sin theta is v naught y
Mhm.
component. Previously there was only v naught x component, horizontal
Yeah.
launch. Now we have also the vertical component V naught sine theta.
Okay.
You know how to take components, right? V naught means V naught cos theta will be
Like
along.
trigonometry?
Yeah.
Yeah.
Okay. So the side with which it makes the angle theta, that will be cos theta, and the other side will be sine theta.
Okay.
Okay. So V naught cos theta is this horizontal component, this vertical component. One thing we can immediately get is a okay. Before that, the basic thing is this curve is this curve is called trajectory, right? The path of
Yeah.
the body, and if you draw this is the highest point, this point is the highest point. Okay. So with respect to the highest point, the curve is symmetric from left side and right side, right?
Yes.
So that's why it's called symmetric launch.
Okay.
Okay, because from the highest point, the middle point,
Mm-hmm.
and whatever the time it takes to go from here to here
Is the same.
is the same as the time to go from here to here.
But in an asymmetric launch, the time is different.
Yeah, I'll come to that. Let's
Okay.
finish this one. Okay, so if the total time is capital T, then this time will be T by 2, and this time will be T by 2, where T is the time to go from here to here, the full path.
Okay.
Okay, it's easy to find capital T by 2 using this equation. See, the noticeable the thing about the maximum point is here V naught Vy is 0.
Yeah.
Okay, so we can use that Vy equal to
0.
Ay capital T by 2 plus V naught y. Is this equation clear? V equal to At plus V naught.
Isn't that one of our physics equations?
Yeah,
Yeah, that makes sense.
V equal to At plus V naught, right?
Mm-hmm.
Here we are considering the y component, so I'm just putting Vy
Mm-hmm.
and Ay and V naught y, and the time is T by 2 because the time to go from here to here.
Okay.
Okay, so from this I can get T by 2 as 2 V naught sine theta divided by what is Ay?
AY?
Yeah, acceleration in the y direction.
Negative 9.8.
Yeah, G. We can take the value later. So, so the capital T is 2 V naught sine theta by G,
Okay.
and capital T is the time of flight, the total time.
Mm-hmm.
Okay, so from this I can find the range. What is range? Range is this distance.
The horizontal.
The
Like
whatever,
X.
yeah, whatever the distance covered in the x direction, that is range. So
Okay.
that will be equal to V naught
Plus AT.
into capital T.
Isn't it
Uh,
X equals VXT, delta X equals
yeah,
VX?
x equal to Vt plus x naught,
Okay.
and x is this r range,
Mm-hmm.
and velocity is V naught x,
With
because
time.
V naught is go V naught at any time is
Mm-hmm.
equal to V naught. Sorry, V. Hold on. The x component of velocity at any time
Mm-hmm.
is same as the x component of velocity at time t equal to 0, because x component velocity is constant. There is no acceleration in x direction, right?
No.
So the velocity in the x direction is same.
Mm-hmm.
So that constant velocity, that is V naught x into t. Capital T
Okay.
is the total time of total flight time, and capital T I have found. And what is V naught x? It's V naught cos theta. Yes,
Yes.
and capital T is 2 V naught sine theta by g.
Couldn't you just use tan
Tan is sine by cos, right?
or tan inverse?
No,
Okay.
we have only sine and cos. The x component of velocity is v naught cos theta and y component is
Yeah.
v naught sin theta. Only we have sine divided by cos, that is tan. This is here we have sine into cos.
Okay.
Okay, that is not tan.
Okay.
So whenever this is symmetric projectile motion. So whenever it is, the first thing to do is to calculate time of flight, so that we can get by this half motion, and the time taken to go for this half motion is capital T by 2.
So 1/2 t,
Yeah.
and then
From that I can get T, because
you can get the total time, just t.
yeah, this you understood, right? This from this
Yeah,
only.
I get finding the halftime.
Yeah, from the half time you can get full time.
Yeah.
Multiplying by 2. So this 2 is here.
Okay. And it's the same for vertical and horizontal.
Yeah. The time is same for both.
Okay.
The same clock, right? It's one single clock.
Yes.
But the other things will be different for x and y. Time is the
Okay.
connecting thing, which is same for both x and y. Okay. From that I can
Okay.
find range as x component velocity, that is not changing, v naught x into total time.
Okay.
So this is symmetric, this thing. If it is asymmetric means you have to, it will be like if from height I am projecting, okay, and the ground is here. This is a building or a
Yes.
hill or something. So here the motion will be like this. And this is the highest
Okay.
point. Okay, so about this highest point, it is not symmetric, right?
No.
So this is asymmetric projectile. You
Okay.
know what is projectile, right?
Yeah, projectile motion.
Yeah. So this is asymmetric projectile when you are shooting from a height. Okay. Here in this case, the time to go from here to here, it's not same as the time to go from here to here. They are
Yeah.
different. Okay. So you have to find the time differently. Again, you can find this time, say t1,
Mm-hmm.
and then I have to find this time t2. Now in this case, capital T will be t1 plus t2. Here t1 and t2 are same.
Okay. So
It will
when
be,
if you were to solve for t, in that problem, would you use different equations for both?
yeah. Here I have to find t1 separately,
Oh, I see.
and then t2 separately, and then add
Okay.
them up.
But if you were gonna find like your time for x, you'd only use the variables for x. And it would be different from finding the time for y. Because
No,
when you
no,
solve for time with y, you're only using the variables for y.
no. The time is same. I'll just show. So this is the
Okay.
y motion. Okay, v equal to at1 plus v naught. So this is y motion. So let me put y
Mm-hmm.
here. Okay, so vy at this highest point is 0,
Yeah, the maximum height is always 0.
and acceleration is minus g, and
Negative
then
9.
t1, and then this is v naught sine theta.
Okay.
Okay, so from this I get t1 as v naught sine theta by g.
Okay.
Now next I can find t2. Okay,
Yes.
so this is my x and y axis,
Mm-hmm.
and let this height be h,
Okay.
height of the building. Okay, so to get this time, I have to. So here, this vertical distance, right? So I can use this thing is equal to half at square plus v naught t plus x naught.
This is a dumb question, but why are you using different like equations for both?
Hold on.
Okay.
This is y. No. See, you'll just get used to it. Just accept what I'm doing.
Okay.
Just hold on. You'll understand.
Okay.
So this equation, understand y equal to half at square, ay t square plus v naught y plus y naught. This equation, it's clear.
Yeah,
Now,
I know that equation.
yeah, you have x equal to half at square plus v naught x plus x naught, right? So
Yeah,
same
I
thing
get it.
for y. So here, in this case, if you're going from here to here, the initial y component velocity here is 0.
Yes.
So this thing will become 0
Mm-hmm.
and y naught is known. Sorry, y naught is again 0. Y naught is this height, right?
Yeah, 0?
Not 0.
No, it's whatever number it is.
It
So
is
just plus y 0. It's why not?
y naught is h plus something. Okay. See, another thing I can do, I can take this full thing,
Mm-hmm.
and I can take this full path. Okay. For that
Mm-hmm.
full path, uh, the initial velocity is v naught sine theta into t1 plus t2 the time,
Mm-hmm.
and y naught is h, and acceleration is minus g,
Okay.
t1 plus t2 whole square, and this y
Mm-hmm.
is 0.
It's
That is
0?
at this point, the final y.
Mm-hmm.
Okay, so from this I can get t1 plus t2. It's a quadratic equation. You know how to solve a quadratic
Yeah, I
equation?
could just put it in my calculator.
It will not give.
Okay, can you show me then how to
Uh,
solve it by hand?
Suppose
Oh,
this,
it's t squared. I would just FOIL it.
no, suppose I put y equal to 5 and then a as 1.
Yeah, I know how to do this. I know. Yeah, I would factor it.
Yeah. Okay, so like that you can solve. So from there I can get t1 plus t2.
Okay, yeah, I get that.
Okay, so I'm choosing my coordinates as this space. Origin of the coordinate system is here. Okay, and I'm analyzing this full motion. Okay,
Okay.
so this is the initial point and this is the final point.
Okay.
Okay, so I'm using this y equal to this one. So y is this final y. So here y
Mm-hmm.
is 0. Okay, and ay is minus g because g is in the downward direction.
Mm-hmm.
And then t is the total time. I can put as capital T or t1 plus t2. Okay, and then v naught y, the initial y component velocity is v naught sine
Mm-hmm.
theta
Mm-hmm.
into time plus y naught is h, this initial height. Okay, from this I can find the time of flight t, which is t1 plus t2. T1 plus is the time of flight, right? I
The
can denote,
total time.
yeah, it's called time of flight, the time which it's flying
Okay.
in the air. Okay, so this is asymmetric projection.
Okay.
So the first one, what we did previously was horizontal launch, where the initial y component velocity is not there. This is
Mm-hmm.
symmetric launch ground to ground, and here it is from a height. Uh, just one more complication. See, if we just look at this part only,
Mm-hmm.
I'm chopping this one. So this part, this is symmetric.
Okay.
Okay, so only because I'm going below this initial height, it becomes asymmetric.
Okay.
Okay, so if you're balancing this projectile motion only from this height, say to a say there's another building here. Okay, so I'm shooting here from here to top of the same building, which has got the same height. Then it will become symmetric.
Okay.
Okay, but here I'm shooting from a building to the ground. There is a height difference between the initial point and the final point. Then it will become
Yeah.
asymmetric.
Oh,
Right?
yeah.
This part of the motion is symmetric. Okay, if I'm stopping at this point, say this is the second building of same height h, it goes from this building and stops at this building. This is a symmetric projectile. But if it continues to go and hit the ground, it will become asymmetric.
Okay.
Okay. So this is the basic idea. So I think you try the question first, then I'll discuss. So this second thing you got right. What was the third one?
What? The third one?
Yeah.
We only had to do 1 and 2, so I said I would do 3 and 4 later. But I can, like, I think I want to do it now.
Okay.
Okay, so I know that my initial, like, x sub 0 is
No.
going to be,
First thing is to have the information in the diagram.
oh,
So here,
right.
right.
So my initial velocity v sub 0 is 75 meters per second for x. It takes 7 seconds, so my time is 7.
That's how
And that's it.
that's how written here, right? And then I also drawn the path.
Yeah,
So this is how you got to draw the figure.
okay. So I'm on my iPad. V sub 0 for x is going to be 75 meters per second. Acceleration is going to be 0. Time equals 7. V is also 75 meters per second horizontally. X and x sub 0. I don't know what x and x sub 0 is.
X is distance, right?
Yes,
This is
which
x.
I don't know.
Yeah, but we can calculate the. See, the easiest thing to do is the time of flight.
Mm-hmm.
The time of flight is how much?
7.
Yeah. So once you know the time of flight, you can find this range, right?
Okay. No, my teacher says that we have to fill it out, like make a table first with x and y, and then we can solve.
No, no. Well, you cannot do that. That comes in the end while drawing the graph. That is the last step.
No, like just an x and y table, like v sub 0 for x equals 75 meters per second. And then x sub 0 is 0,
Yeah.
okay? And then the equation I could use is x equals vt plus x sub 0.
Yeah.
Then x is going to be 75 times 7
Hmm.
plus 0. So x is just going to be 525. So my distance, my range is 525.
Meters.
Yeah, meters. Okay, and then for y, I know that my initial velocity is 0.
Yeah.
What?
Yeah. That's right.
Okay. A, my acceleration is going to be negative 9.8 or negative g. T is 7. Okay, so my initial velocity is 0. My final velocity, I don't know.
You can calculate, right?
No, I don't know. Yeah, I have to calculate it, but I don't know it initially. And then I have y and y sub 0.
No, have you find the final velocity y component?
No?
You can calculate, right? It's
Yeah, I know.
summative.
Yeah, but I don't know what y and y sub 0 is. Yeah, y is x. Like y I don't know, right?
You are using v equal to at plus v naught, right?
No, I'm still like figuring out what I have and what I don't have. Wait,
You
is
have
y
to
sub 0 0?
just see what you have and then see what they are asking for.
Okay, they're asking for the final speed, so that's v.
Huh?
Vertical velocity, v.
Yeah.
So I would use v equals at plus v sub 0.
Hmm.
So v equals at plus v sub 0. V I don't know. Negative 9.8 times 7 plus 0. So v is negative 68.6.
Yeah. What is the final speed?
Negative 68.6 meters per second.
No, final speed. Speed is square root of vx square plus vy square.
Wait, what?
Speed is square root of vx square plus vy square.
Really?
You can see the screen, right?
Yeah, but
Huh.
isn't this?
Speed is
Oh,
magnitude of the velocity, right?
yeah.
Huh. And magnitude of the velocity is vx square plus vy square.
Yes.
And this is just vy. And what is
Is this
vx?
Pythagorean theorem?
What?
Like Pythagorean theorem, like a squared plus b squared equals c squared?
Yeah, yeah.
Okay. So if I were to draw like a triangle,
Why do you have to draw?
I don't know. That's what we always do in school if we don't know it. So what does Vx stand for? That's your vertical velocity for x, right?
No,
Your
no.
horizontal velocity.
Horizontal velocity. V is velocity. Which,
Yeah.
which
But
is it's
is that your initial velocity or final velocity?
Vx is not going to change, right?
Yeah.
Huh. It's the same throughout.
And then Vy, is that your initial velocity or final?
Final.
Okay.
What is he asking for? Final speed, right?
Yeah.
Now then,
Okay, so then when you do that, you get 101.6.
okay. Is that they have given the answer?
Yeah, let me check it. Yeah, it's 101.6 meters per second.
Yeah.
Wait, so can you explain once again why we found, like, why we use the Pythagorean theorem and to find the final speed?
See, velocity is a vector, right?
Mm-hmm.
So it will have two components, x component, y component.
Is this the velocity of both x and y?
Yeah, but if you consider velocity as a vector,
Mm-hmm.
see, vector means it will have some direction, right?
Mm-hmm.
Vector means it will have some direction. Okay, and say this is my x-axis and this is my y-axis.
Mm-hmm.
Okay, so the component along x-axis will be vx. Suppose this is v, and the component along y-axis will be vy.
Mm-hmm.
Okay, so if you want to find this vector is denoted by this, right? So if you want to find this magnitude of this vector, it will be square root of vx square plus vy square by Pythagoras theorem.
Okay.
Okay, and speed is magnitude of the vector, magnitude of velocity.
Mm-hmm.
So magnitude of the velocity is square root of vx plus vy square.
Mm-hmm.
This is very basic of vector.
Yes.
Okay,
Mm-hmm.
just go over it again after I finish this session.
Yeah.
Okay, and the third C part.
Would the pilot pass over the climbers before, after, right after when the rescue package hits? Explain your answer. So,
Did you understand the question?
yeah. It's
See,
asking me if I pass like
see
the
the, the,
climber.
pa- the package is moving from here to here, right?
Yeah.
During the time the flight would have moved from here to somewhere, right?
Yeah.
So where would have moved when the package is hitting this ground? The airplane will be here,
Yeah.
or here, or here, or here, or here. Where it will be? That's what I will find out.
Like you gotta use math.
Yeah.
Okay. So um
See, we basically have to find the x of the pilot. This is x direction, right?
yeah.
So we have to find the x of the pilot and the x of the package.
What do you mean by x?
X means the distance covered in x direction.
Oh, this okay. So I know that the distance for x is 525. So I have to find it for y
No,
now.
no, that is the final distance. Okay, the final distance is x 525, right?
Yeah,
What about the final distance of this plane?
525
How do you know that?
because that's like the total distance for our horizontal motion.
See, uh, you're seeing my screen, right? This equation, understand x of the pilot is velocity of the pilot in the horizontal direction with the time. This is at
Seventy-five xt.
x at any time,
Mm-hmm.
75 into t, because 75 is the velocity of the pilot or the plane.
So that's not gonna change. That's constant.
Yeah, and even the package, this thing is not going to change.
Why is it 75 too?
Because see, initially it's being released with 75, right?
Yeah.
After that, there is no acceleration in the horizontal direction.
Yeah, but isn't the package y because it's dropping?
Both x and y.
Oh,
But you just analyze the x motion now. Forget the y motion.
okay.
Okay, so the x motion velocity is constant.
Hmm.
So the x of the package is also 75 into t. So at any time instant, the x of the pilot and x of the package will be same. So this is like, see, at 1 second, the package has reached here and the plane has reached here. At 2 seconds, the package has reached here
So they're at the same spot.
horizontally. Okay, the package has reached here and the pilot has reached here. And when it hits the ground, the airplane is here.
Mm-hmm.
Okay, because the horizontal motion, the velocity is same for both.
Yes.
So got it?
Yes.
So when the thing hits the ground, it will be just above that point.
Okay.
So after I finish, you try this question once again without looking at the solution,
Okay.
and then look at my solution and see whether you're getting it correct.
Okay. There's one more on this page.
Yeah, you try this. I'll come in 5 minutes.
Okay, yeah. I can do it. I got like my height is 33.3.
Okay, check the answer.
Um, okay, 33.3 meters.
Is it correct?
Yes.
You can see my steps, right?
Yes.
Okay. Right. So basically, I have chosen my origin of coordinate system as here.
Okay.
Okay. So with respect to that, if I write this equation, y will be 25.
Mm-hmm.
Okay. And v naught t is 0, y naught is h. Okay. And acceleration is minus g. And t I found in the first part.
Okay.
Right. Okay. Uh, okay, you can revise this thing again after you've, maybe you can leave some gap and then revise.
Okay.
So this also you should be able to do the same way. But the only thing is in the horizontal thing, v naught y was 0. Here v naught y is not 0. That's the only difference.
Okay.
So can you try this first one?
Okay. Um. Um. Oh. Okay.
This angle
So
is how
it's
much?
showing a speed of 11 meters per second. So is my initial velocity 11 meters VO?
Yeah, v over v naught.
Okay. And then, so VOY is going to be sine of
How much is this angle?
20 times
This angle is how much?
20 degrees.
Okay. So v naught x is how much?
V naught X.
Yeah.
Oh, wait, I haven't finished solving yet.
No, this is the starting point, right?
0?
Y 0, 11 cos 30.
Oh, that's what I was saying. I haven't finished solving it yet.
It is not, there's nothing to solve it. This is the first step.
Okay, so yeah, cosine of 20. Wait, why did you write cosine of 30?
Sorry.
Okay.
Cos, you can just write capital C and then suffix as 20. Okay, and how far does she jump? That is range, right?
Yeah, I have to calculate that. So that's X.
Yeah.
And then how high, that's height. Okay, so my first step is I have to take the sine of 20 and then the cosine of 20.
No, calculation doing the end.
Okay. So,
So how do you do?
so, okay, so sine is going to be
Range is V naught x
opposite.
into
So it's going to
capital
be
T, right?
VOY over 11.
Range is V naught x into T, right? Capital T, where capital T is the time of flight.
Isn't it VXT? Yeah, that's right.
So I have to find the time of flight.
Okay.
So how do you find time of flight?
Oh, we could use 1/2 AT.
We have to analyze the half motion. So the maximum point Vy equal to Uy plus Ay t by 2.
Isn't that the same equation?
V naught y. Is this equation clear?
Isn't it the same equation that we already have?
Where we have? I have only
Like,
one. I have written only one equation. This is the first equation. This is the second equation.
okay. Okay.
So from this, how do you get one?
You
At this
just,
maximum height point, what is Vy?
at the maximum height, Vy 0.
And what is V naught y?
V naught y, sine of 20.
11 sine 20, right?
Wait, why is it 11?
11 is
Oh,
the.
no, never mind, I got it.
And what is Ay?
Negative 9.8.
G.
Oh, sorry. And then,
So from this, I can find capital T.
wait, never mind, I didn't get it. How did you get 11 times sine of 20?
That is V naught y, right?
Yeah, how did you get the 11? No, I know, why is it 11?
Speed is 11, right? What is speed? Speed is magnitude of velocity.
Yes.
Uh, Speed is magnitude of the velocity.
Um,
This is the velocity vector. So this length is how much? 11. And this is x component. And this is y component. This angle is 20 degrees.
yes.
So this 11 cos 20 is x component. 11 sin 20 is y component.
Okay.
Magnitude of the velocity vector is the length of the vector.
Yeah.
Yeah. So the x component is that length into the angle, cos or sine. Okay.
Okay.
So from this I can find capital T.
So 3.76 plus um so 13.5.
So no, I don't know the value. After that, you put in this and find R.
So R is VOX is the cosine of 20, right?
11.
Yeah.
Uh,
Okay. So that's 10.3. Why are you multiplying the cosine of 20 and the sine of 20? Oh, because it's VOX.
then the
Okay.
value of capital T. So now we can use a calculator.
Yeah. So you get 14.09.
Check the answer.
Um, I did something wrong with the math, like plugging it into here. Okay. Yeah, your Y max is 0.72.
The value of R is correct or not? This value.
Oh, no, I made a mistake when I was putting in my calculator. It's 7.96.
What is the answer key?
7.96.
Okay, you got it now?
No, yeah, I made a mistake when I was typing it in.
So now you got it correct?
Yeah,
Okay. How high does she jump?
you would use,
How high is this distance side?
yeah, V equals AT
So you
plus,
have to find y at t/2 time.
okay.
Okay. So I can use
So
v square equal to v naught square.
couldn't you do V equals AT plus V sub 0?
You have to find y, right?
Yeah.
So if you use this one, v square equal to v naught square plus 2a y,
Mm-hmm.
this v is 0, right?
Yes.
And v naught square is 11 sine 20 square minus 2g and this height h. Suppose I call this height h. Okay, so from this I can find h.
So what's Y? 2AY, what's Y?
Why is this? I'm taking this point, right? Maximum height point.
Oh, so I don't know why.
How high does she jump is this height? No.
Yes.
That value of I am denoting as h, maximum height. So from this you get h as 11 sine 20 square by 2g.
Um, 0.72.
Check the answer. It looks too small.
Y max is 0.72.
What is the answer?
0.72.
Have they given what is the answer key?
They did Vy squared equals 2a delta y plus Voy squared. They said 0 meters per second squared is equal to 2 times negative 9.8 meters per second squared.
Answer key they are given.
Yeah, it's 0.72 meters.
So you got it right?
Yes.
Say that, no. Okay, so you understood, right? You just
Yeah.
revise it again after I finish this one.
Okay.
Okay, so basically, see, the best things to get the time of flight, you have to catch this maximum height point. At the maximum height point, the y common velocity is going 0. So from there, I
Okay.
can get the half time of flight. Once you know the half time of flight, I can get the full time of flight. Once you know the full time of flight, I can get the range.
Okay.
Okay. After that, I can use V square appropriate equation to get the other things.
Okay.
Right. So the thing is, your test is on Monday.
Mm-hmm.
And what are the things quotient for the test?
Everything, the whole kinematics unit. So from displacement to position versus time, velocity versus time, acceleration versus time, to free fall, this,
So
everything.
what are you going to do in this weekend? Only this physics test or something else is also there?
No, I don't have any other tests, but yeah, I'm gonna study for it. I think in like the beginning parts of kinematics, like displacement, distance, I'm solid on, like I can do it. I think I just need more practice with the horizontal and vertical problems along with like some vector stuff and then a couple of free fall problems.
Okay. Right. Okay, I'll send the solution for these ones. Okay.
Okay.
And then we'll discuss after that. So you try to do these things on your own. Horizontal lunch now you should be able to do on your own. After this first question is clear. So based on this first question, try the second one also because it's very similar.
Okay, I will.
The basic thing is to get the time of flight, get this maximum height point.
Okay.
So you know the half time of flight.
Yeah.
From there I can tell full time of flight. And once you know the full time of flight, I can get the range.
Okay.
Okay. So I'll get the solution of this worksheet 16 and 17. This 17, right? Yeah. I'll do that one and then I'll send it to you. Meanwhile, you try. So you try this 15, 16, 17 and the
Mm-hmm.
previous one also. And then I'll try to catch you in the morning.
Tomorrow morning for me?
Yeah, your morning time.
I don't think it's gonna work because I have school at 7:30.
Okay, then tomorrow is same time.
Tomorrow night. So Saturday morning for you.
Yeah, by that time I'll send the solution.
Okay, that works.
Right?
Yeah.
To try the other ones also. Okay, right now you'll be away for some more time, right? So try this one, it should not be
Yeah.
difficult. Okay,
Okay.
listen this.
Okay, yeah, I have another assignment I have to do, a couple more. So after I get those, it's not physics for other classes, and then I'll do this.
Okay, fine. Okay then, bye.
Okay, thank you. Bye.